and this is a screenshot of a previous video. This was the day 3 of our cabbage and lactic acid fermentation video, where I had my mic muted throughout the video. So I thought what I'd do is just narrate over it, and one of the good things is we can speed it up. So I'm going to use this little gear. I think I'm going to speed it up. Okay, playback speed. Why don't we go to, often I'll do it at 2 times, but how about we'll do 1.75 times, okay? And then we'll go full screen, and again, I'm going to try to narrate it over it, folks. So with this experiment, you'll recall that on day 1, we set up different batches of chopped cabbage and carrots, and the variables we were changing were whether or not air would be present. So we ran some samples aerobically, meaning the bags that they were in weren't sealed, so air had access. And then another variable was whether we added salt or not. And then I did 2 more variations. So in one, I left it aerobic, but I added excess water, and oxygen does not diffuse well through water. So that was like, even though the bag wasn't sealed, hopefully the excess water was creating an anaerobic environment, and that didn't have salt in it. So what we're trying to figure out is in the way we traditionally make sauerkraut, sour cabbage, is in a container. You add layers of salt, excuse me, you add layers of cabbage and then salt, and you pound it, and then another layer of cabbage and salt, and you pound it. So because of the salt creates this hyperosmotic environment, you'll have a net flow of water out of the plant cells into the surrounding, right? So that again will help create that anaerobic environment, and pounding it, you're getting rid of any air. So my question is the salt necessary, or is it just the anaerobic environment that's necessary to select for the growth of lactic acid bacteria that carry out the lactic acid fermentation? So is it just the anaerobic environment that's required, or is the salt also required? Now, salt will help inhibit some spoilage microbes. So salting food traditionally has been a way to preserve food in the absence of refrigeration. So we're just doing this experiment to see um, what were the best conditions for selecting for our lactic acid bacteria, which are present everywhere, right? They're on the mucous membranes of animals like ourselves. We can find them wild out in nature. Okay, so let me see if I can get through this narration here. Okay, so this first part was just showing you the variables. So this was our negative control, the chopped cabbage, aerobic, no salt, and we're going to keep it at room temp. And then there's an aerobic with salt, and I think we had about 200 grams of cabbage, 200 grams of cabbage, about 7 ounces of cabbage, 2.5 cups of cabbage, and a teaspoon of salt was the treatment. And then we repeated this, but in this case, we sealed the bags. I tried to squeeze all the air out. We sealed the bags, so we had anaerobic no salt and anaerobic salt. And it's hard to see down here at the bottom, you guys. So another negative control was cabbage just in the bag, no salt, back in the refrigerator. Okay, that would be normally how we would store our chopped cabbage. And then another one, again, folks, was aerobic, no salt, but excess water. And so what we did was we pH'd on day 1, and the pH of the cabbage on day 1, folks, was pH 7. So if we get a lactic acid fermentation going on, we would predict the pH should drop from pH 7 possibly all the way down to pH 4 or 3. So that's going to be one signal. So folks, this was our aerobic no salt, our negative control, after 48 hours of room temperature incubation. And you can see, folks, there's not much fluid here, right? And it smelled like cabbage. It didn't smell horrible. It didn't smell like lactic acid fermentation, though. And what we're going to see, especially on, let's see here, we'll be filming again today, day 5. The cabbage is starting to turn brown. It looks like it's starting to decompose. Okay, so now this is our aerobic with salt. And again, folks, notice how the salt has created this hyperosmotic environment. We have a net flow of water out of the plant cells into the surrounding. So we have some liquid there that would help create an anaerobic environment, even though the bag's not sealed, right? And again, so here with the salt, we have not only the salt is going to inhibit some microbes, but maybe that little water is going to help create an anaerobic environment. And then this was our aerobic plus excess water. And the cabbage and carrots were looking great, right? They hadn't oxidized, they weren't turning brown. And what was interesting was the pH on the aerobic excess salt, the pH had dropped to about pH 3 to 4, and it definitely smelled like lactic acid, you guys. It smelled like sauerkraut. And I forgot to tell you, folks, the pH on the aerobic and salt was pH 4. So it looks like in both the salt aerobic and the excess water, no salt, the pH had dropped from about pH 7 down to pH 3 to 4. So that was encouraging. And also the aroma, when you smelled those two batches, they smelled like lactic acid. They're starting to smell like cabbage. Now on this day, you guys, I didn't test the anaerobic ones. I thought we'd wait till day 5. But what I did do was I took samples from each of those 3 bags, and then I re-streaked them to TSA so we can so we can compare maybe the variety of microbes that were growing on day 1 and then compare them to the variety of microbes growing after 48 hours of incubation. And I'll be showing the day 3 plates in a follow-up video. Okay, so this was on day 1. This was on day 1, and I believe that was the cabbage plus salt. So I harvested some of the juice, right? So we have some good microbial growth. That's on tryptic soy agar, all-purpose, so we know we have a variety of bacteria and fungi, maybe yeast growing. And this was the day 1 Sabrod's dextrose medium, and you recall, you guys, Sabrod's dextrose, it selects for the growth of fungi, including yeasts. And what was interesting, when I opened this plate, it smelled like ethanol. So I was like, oh, I think we do have some maybe Saccharomyces in here doing an alcoholic fermentation. But check out this really cool colony down here. This is just wild. At first I thought, is that purple from the purple cabbage? But it's actually a purple colored colony, and it's really snotty, really mucoid looking down here. God, that's so cool, isn't it? So maybe suggesting it's making a slime layer or a capsule of some type. And it'll be interesting to see if after fermentation, if that same colony is going to be present after 48 hours of lactic acid fermentation. So that'll be kind of fun to see. Okay, folks, so I think that was kind of the key points here. So I'm going to go ahead and close down this video, and then we'll post this so you actually have some narration to go with it.